1 in 5 workers nowadays works entirely remote. And working remote comes with its perks. A 10-foot commute time, some more bearable coworkers, and not having to wear pants. Hey, I'm wearing pants. Chill. While there are many pros to working remotely, there's some key drawbacks. Number 1 being the IT department. If you work remotely, chances are your boss is keeping tabs on things like your idle time. Basically, they're seeing if your mouse is moving or not. If your mouse isn't moving, that means you're not working, which means you're costing the company money, which means you're decreasing shareholder value, which means that the CEO is going to have to settle for a slightly smaller yacht. And we just can't have that. In all seriousness, you should get your job done if you're getting paid to do a job, and that's all I'm going to say on that. If you want to get around IT snooping around, you can get something called a mouse jiggler. These devices move your mouse in a certain set pattern, simulating you actually working when you really aren't. To combat this, IT departments have deployed sleuth bots to see who in their organization is using the top 50 or so mouse wigglers on the market by tracking their mouse patterns. I read an article somewhere that an organization that has mostly remote workers found that 80% of their workers were using a mouse wiggler at one point or another. The only sure way for getting around these sleuth bots is if your mouse wiggler wiggled your mouse in a truly random pattern. But what does it mean to be truly random anyways? Pseudo-randomness is found in things like random number generators. These are essentially algorithms for generating sequences of numbers whose properties approximate the properties of sequences of random numbers. True random entails things like quantum events, radioactive decay, and thermal noise. The second law of thermodynamics states that in any energy transfer or transformation, the total entropy in an isolated system can never decrease over time, meaning that processes tend to move towards greater disorder. Entropy is just a fancy word for the amount of messiness in a closed system. It's basically nature's way of wiggling the mouse without a plan. But how are we going to achieve something that at least resembles true random? I got to thinking about what people do when they're avoiding work while they work remotely. Things like eating, sleeping, and walking the dog. Then it hit me. Playing video games. If we can somehow take the inputs from our PlayStation controller and map that onto a mouse wiggler, that is about as random as we can get without a Geiger counter. But this isn't truly random. Our actions feel spontaneous, but your brain is responding to inputs. Things like goals, strategies, visual cues, and muscle memory. Every flick of the joystick is based on intention, reaction, and habit. In physics terms, if your IT department could somehow map the entire state of your brain and the environment around you, they could predict your mouse's movement with 100% certainty. Another problem with this is the physical constraints of the controller. A joystick can only move in 2 axes with a fixed range of motion. Movement is analog, but it's bound by mechanical stops, spring tension, and resolution of sensors. Even if you try to move randomly, you're still limited by how fast your thumb can move, how far the joystick can travel, and how fast the controller translates analog inputs into digital signals. And these are generally values from 0 to 255 or -1 to 1. Even without these physical restraints, there's still the fact that humans are just plain terrible at being random. When asked to pick a number between 1 and 10, people often avoid extremes. Pick a number between 1 and 10.
7.
Science. When choosing heads or tails or left and right, we often subconsciously form patterns. In some studies, human attempts at randomness often always have statistical fingerprints, like clusters, streaks, and biases. Human movement is very low entropy compared to things like radioactive decay and thermal noise. It has structure, energy input, and purpose. All this to say we can't create something that's truly random with human input, but I seriously doubt that our job's IT department is going to tell the difference. So how are we going to bind this PS5 controller to a mouse wiggler? My initial thought was to tap into the signal coming from the joystick and send that to the mouse wiggler. Then I found out PlayStation uses Bluetooth encryption, so hacking into a signal is near impossible for someone like me, so I'm not going anywhere near trying to go that route. I settled on something more mechanical and elegant, making a slave joystick move the mouse for me. I designed this 3D printed linkage to move a joystick based on how I move the joystick on the PS5 controller. The slave joystick will be wired into this Arduino that sends signals to these 2 servo motors that move the mouse back and forth. Oh yeah, I haven't designed or made the mouse wiggler yet. I wired up these servos, then I wrote a quick Arduino script to allow me to control each axis with the movement of the slave joystick. One servo moves up and down while the other moves left and right. I hooked up the servos to a 9-volt battery because they'd pull too much current from the Arduino alone, and that wouldn't give us the pizzazz we're looking for. The servos do a good job at moving the mouse back and forth in one direction, and when paired together they give us the ability to move our mouse not just back and forth, but anywhere on the screen. This is how we're going to achieve pseudo-random, by playing Elden Ring and dying a bunch of times.
Bob Saget.
But hey, at least I'm not working. My initial thought for this mouse wiggler was to push the mouse in two directions with the servos.
But screw that idea. That idea is trash. We want to be able to quickly pick up our mouse off the mouse wiggler if our boss calls us into an impromptu Teams meeting. And if it's tied up in some weird linkage, it's just not going to work and we're going to miss the call. I mean, sure, we can just buy a second mouse and switch out the mouse whenever our boss calls us or we need to use our computer, but I really don't want to buy a second mouse, and I have a big brain idea anyway. Instead of pushing the mouse back and forth on the desk, we put the mouse on a platform and tilt the mouse back and forth. That way we can pick up the mouse whenever we want and put it back down when our boss leaves us alone.
With the parts done printing, it's time to assemble this thing. The base holds the two servos and provides stability for the platform and the mouse moving around on top of it. I use this piece of Delrin instead of printing it because it seemed like a waste to print something I can just get for pennies. Plus I had to match drill the holes for this because I wasn't 100% sure where I needed the holes to be without testing it.
I just drilled through the table. That's what it's made for. We're good.
These servo arms connect the servos to the platform. I went with a spherical linkage between these two joints to allow the two axes to swivel back and forth so that they aren't over-constrained. The third axis acts as a fulcrum between the two moving axes, and it also gets a spherical joint. I wrote some more code to get it to move the way I wanted it to. I put some logic in that says if I idle too long, like if I'm stuck in a long cutscene or if I go grab a sweet treat, to wiggle like a normal mouse wiggler would and return to joystick input once I return. I figured this is fine as long as I'm not gone for too long. The stationary axis wasn't allowing the two moving axes to actuate low enough and was hitting the Delrin, so I extended the stationary axis to allow for the larger range of motion. Another issue I ran into is that the platform had all these ridges from 3D printing, and it's creating too much friction to allow the mouse to slide across it. I decided to try pouring a thin layer of epoxy on the platform to create a smooth surface for the mouse to slide on. I've never done anything with epoxy before, so we're going to figure it out together. Apparently, I didn't read the directions well enough because the first pour came out super tacky after waiting a couple days, so I reported it a second time, making sure to stir the epoxy for a solid 4 minutes straight. After waiting 3 more days, the epoxy came out great, but the surface still had way too much friction to allow the mouse to move. With all other options exhausted, I had an ace up my sleeve. Blue painter's tape. I threw a layer on the platform and on the bottom of the mouse, and now it slides like a dream.
Oh, yeah. That is the ticket. Who'd have thought? Blue tape. Just wasted a week. Well, I could have just used blue tape. There you go. Yeah. That's what we're going for.
Now it's time to test this thing. I ran about 15 feet of wire from the wiggler to the controller because, again, I'm not a computer engineer and I know pretty much nothing about Bluetooth. If I wanted to improve on this design, that would be one of the first things I would try to implement.
I thought it was going to make it hard to play, but it doesn't. It actually, it makes it easier to play because I know that I'm committing like that. The best part about this thing, oh shoot, I'm getting a Teams call or something. I just got a work email that said, somewhere I have to pick up my mouse and use it. Oh no.
Yoink. There we go. Oh, and now we're done. There we go. like I said before, guys, and I'll say it again, it's not right to commit time theft. You shouldn't do it. I don't work from home. I just had this really dumb idea, and here we are. Yeah, you're welcome. Thanks for watching it. Anyways,